Hi everybody. So we're putting the cart before the horse a little bit on this video because I'm shooting the intro at the end of this video, and the reason is this story has really changed a lot since it started. So what we have in progress back here, I don't know if you can see it, is a Hallicrafters model SX42 communications receiver. When it came in, it was supposed to be functional. Everything was supposed to be good on it, except when the user was listening to it, he saw a little puff of smoke and the radio went silent. So of course, normally when that happens, the normal thoughts go through your mind. A capacitor shorted out, a vacuum tube went bad, something like that. So my thought at the time was, we're going to troubleshoot this thing, we'll figure it out, then we'll go through and do the alignments, check them out, make sure it's good. It was supposedly had been serviced, and it had been, in fact. It had been at least mostly recapped. I'd say a good 80% of the capacitors had been replaced, and it looked like all of the out of tolerance resistors had been replaced, and it had been thoroughly cleaned, with the switches at least, but it was still a pretty vintage radio. In other words, the chassis wasn't torn down and totally redone, but it was pretty clean. So my thought was, well, this is going to be a slam dunk. Well, yeah, no preconceived notions from now on. I should have known better. So anyway, the first thing you need to understand about one of these radios is there were many different revisions, and there are many, and I say many, different schematics for these. Some of these revisions were done at the factory at the time of production, in which case there would be a specific schematic for that rev level of version of this. But some of them were mods, and what a lot of these turn out after all these years is they may have been made at an earlier date with an earlier circuit design, and then either the factory, it was sent back to the factory, or an authorized service station, or the individual who owned it put some of these modifications in themselves. So what ends up happening is you will have a radio that none of the schematics totally match. In other words, you'll have little bits and pieces from one schematic that are present in this circuit, and you'll have little bits and pieces from other schematics that are present in this circuit. And that's really what we have here, and this is kind of what we got into with it. What I also found out was there were many more things wrong with this radio than what caused it to initially to fail to have it come here to my bench. I honestly don't really know how the thing even worked in the state that it was in, because there were so many different problems. So I just thought I would give this little intro talk to get you up to date. The video is going to skip around a lot because I did a lot of footage. Some of it was just on the fly as I was thinking and working. Some of it, I kind of would get to a point and then update you. I'm going to try to edit it in a way that it kind of follows a chronological order, how I did everything. And I have no idea how long this first part is going to be, but what I will tell you, spoiler alert, I do not get it fixed at the end of this part, so there will be a part 2 to this video. It just got too much content, and I thought maybe it'd be better to get the video posted, and then we'll pick up where we left off. At the beginning of the next video, what I'm probably going to start out with is I'm going to put a sweep circuit into it, and or a sweep signal into it, and follow it through. You'll understand when you get through the video. So I hope you enjoy this. If you're into these shortwave communications radios from days gone by, this is 1940s technology. Its unique thing about this one is one of the earliest ones that have FM. And back then, FM was just FM to everybody, if you know what I mean. So you'll see a lot of things that was a learning experience to Hallicrafters when they designed the FM section of this. So anyway, let's get started. Hi everybody, welcome back to the bench. So I actually had to take the camera off of the stand here on the bench and take a step or two back to get this whole thing in the video. in the frame. What we have is a Hallicrafters model SX42 communications receiver. And any of you who are into shortwave or ham radio or anything like that, you probably know this is kind of a legendary receiver. It's pretty high-end gear for its time. It's very old now, but back in the day when this thing was state-of-the-art, it was state-of-the-art. And so much so that even radio stations use this somewhat as a piece of test equipment almost. So this thing, I actually own one of these myself. It's almost in mint condition, and it really wouldn't be much of a video other than a show and tell video because it really didn't need any work or much work at all when I got it. But this one came in from an Elmer, if any of you know what an Elmer is. He's a gentleman who is really into amateur radio, and he purchased this thing. He's wanted one for a long time. They're hard to find good examples that have the clutch and everything, this whole tuning assembly functioning, and this one's in relatively good condition. And he found it and purchased it, had it recapped and everything, got it working, and was listening to it. And he said one day he was at the house listening to it with his grandson, and all of a sudden, puff of smoke, and the radio quit working. So, well, we're going to check it out for him and see if we can find out what's wrong and troubleshoot it and repair the unit. And the good news is most of the hard work has been done for us already. If you notice, this thing has been recapped with high quality capacitors, and the work is very good that was done on it. So hopefully this is something we can figure out relatively quickly, and then we're just going to do a couple touch-ups on this. We're going to go through the alignment and make sure everything's good. Well, hopefully I have this whole thing in shot. Boy, it sure is good to be back on the bench. It's been a busy couple of weeks, so I'm glad to be back with all of you. So anyway, let's take a look at this, and let's start at the beginning. If there isn't any power to the unit, let's start at the power cord and see if everything's working. When we turn the power on, what we should see, if we put this on ohms, we should be able to read the primary of the power transformer. And this cord does not look original to the unit. This is a different type of cord, I think, and definitely not a plug that I'm used to seeing. So we're all connected up. Let's turn on the power switch. And that looks about, well, it's jumping around a lot. Okay. Well, that's 10 ohms, 11 ohms. That's probably reasonable, I would say. Let's look across the power switch. And I still have 7 ohms. Wow. Look at that. That's going crazy. So we have a bad power switch. That's our first problem. And let's see what we have here. That looks to be reading through the winding, which is about 6 ohms. This one should read directly. It's not. So we still have a problem here as well. So this cord looks a little bit funny. Look at this power plug. It says, if you look here, it says fused plug. I don't know if you can see that in the light. And it looks like there's fuses inside here. So let's take this apart and take a look in here as well. We know we definitely have a dirty switch. But even if it's only a couple of ohms, you would think that it would still turn on. I don't know that you would get a puff of smoke. That's what concerns me the most. But we're not even to that point yet. So let's take this. I think this comes apart like this. And there's two fuses in there. Two very big looking fuses. And how do they come out? Ugh, that looks bad. And that's hardly even touching. Look at that. And that's ready to break off. That's not even holding. So we're going to have to put a different plug in there. The other thing, look at the size of this fuse. That's a big filament for such a small 10 amp. I don't think this is a 10 amp radio. How's that for a splice job? You like that? So these are just those little things that they're butt splices and appropriately named because that's what they look like when you put them on, but it's just a little solder ring inside of some heat shrink, and they work really well for these quick little temporary connections. I just tacked on a cord I had laying around just so we can continue testing. We'll put a proper power cord on this when we're done. So let's go back and see, now that that bad plug is out of the way. And you can see we still have problems with the power switch, which we expected. So before we can do anything, we really need to clean or repair the power switch. But what we're going to do for right now is we're going to ignore that and we're going to just jumper it out. So I'm going to solder a temporary jumper in there. Again, all we're trying to do right now is apply power to this thing and see if the problem was just bad power connections. Not a lot of things will make smoke without leaving a sign that something smoked. And I don't see anything in here whatsoever that appears to be burned up. So let's jumper this switch out and make sure we have good continuity to our transformer. Okay, jumper is installed. You can see right here. And let's see, we should see our transformer now. And look at that, 3 ohms. That's more like it. Okay, now we could try to power this thing up. But before we do that, like I said, I don't want high voltage. I just want to check to make sure the filament circuit is working and that our tubes are lighting up. So let me get the 5U4 pulled out of here. Let's move our meter. And move this around. And we'll pull this tube right here. And got a little bit of crud on there, but again, I don't see any signs of red plating or arcing. This is actually just some glue or paint or something that got stuck on there, but this actually looks to be relatively good. We could test it, but I don't think it's going to be necessary. All right, so high voltage is disabled to the circuit, and we're just going to look at our power here. So first things first, we're going to start out over here. And we are going to first go a little bit over an amp. And I'm going to switch this to limit. And what that's going to do is that's going to put the dim bulb tester in series with this light socket. So there's a bulb inside of here. It's just like a dim bulb tester. And when we turn this on, it's just going to ensure that if there is a dead short, it's not going to go through our breaker. So power on, and there are no dead shorts. That's a good sign. And we have lights. Take a look at this. Can you see the light lit up through there? Kind of see where my hand is? I don't know if you can see the lights in there, but they are definitely lighting up. There's one right there, you can see it. Not bad. So the unit is powering up with no shorts. I'm going to leave the dim bulb on first, because again, in case something does go wrong, because the owner said they were listening to it, and while they were listening to it after a while, it actually smoked afterwards. So let's start over here, and let's just take a couple basic tests. Let me find somewhere where we can find some filaments, and we'll check our filaments first. Okay, we're across the filament string, and it's actually not a filament string. They're all in parallel on this one. It's not a series strung. And you can see 5.5 volts AC, and again, the reason that is because we have the dim bulb in there. If we turn the dim bulb off, that'll go up to 6.3. So now what we want to do is we want to look at our high voltage, which is coming out of the transformer, and that should be going somewhere between, if we read between ground and pin 4 and ground and pin 6 of the 5U4. Okay, so there's 242 volts on that side. That's pin 2. And then if we go to pin 6, 3, 4, 5, 6, which is right here. Not getting anything. Am I on the wrong pin here? Oh, I'm way off. 1, 2, 3, 4, 5, 6. I'm sorry. Not paying attention to what I'm doing here. That noise on this is enough to trip this thing. Okay. Same thing, 239 volts. So we have high voltage. So now let's kill the power to this. And now what I want to do is I just want to kind of make a static test of the DC. And the DC on this, if we look on our schematic, here's our high voltage, here's our transformer. We have our 6.3 volts here, and we have this. I'm not going to worry about the 5 volts because I'm sure it's probably there. And what I want to look now is where it comes off of pin 2 of the rectifier tube and goes through your filter choke into the outside world and into this voltage rectifier or voltage regulator. I want to make sure that we have continuity all the way through there. So let's check that. So we want to go from pin 2 to ground. And we're just statically checking to see if we have any kind of a short. So there's pin 2. And if we go over to here, you can see there's no shorts. And I wouldn't expect there to be. I'm kind of reading through a capacitor right now. So that all looks good. All looks good indeed. So we're going to put our tube in now, apply high voltage, and just see if we get any sound out of this thing. Okay, so I have an antenna connected. You can see up here, and it goes down to my 43-foot vertical outside. I have the volume turned up a little bit, and the machine's turned on. You cannot directly connect a normal speaker to this. You have to have either a special voice coil on your speaker or a matching transformer. So I've put a transformer on here. It's because this doesn't have an 8 ohm output. These have funny output transformers in them. That's one of the issues with these. Some people retrofit them with a more standardized one, but this unit came with the original reproducer speaker, the R42 that comes with it, so there's no need for that. But this is just a temporary thing to get this to work. As you can see, powering and working on one of these is not normal like you would on just a small AM radio. So I'm connected from ground to the output of the voltage regulator tube, which is going to regulate that voltage to 150 volts, which is this little tube right here, if I can get the camera to quit bouncing around. And we're just going to see if we get voltage and how this works. And we're also going to monitor our power. There we go. And I have it set that it'll trip pretty easily if we have any big problems here. It's going to run just right around a 0.5 amp. And you can see I'm still not letting this off the leash. We still have the dim bulb on there. And we're getting roughly 150 volts. But we're not getting any sound whatsoever. Now that could be because we don't have enough voltage, or it could be because there is a problem. So I'm going to let this off the leash. And the reason I am is because I have this set to trip at about 1.5 amps. So if something goes wrong, it'll shut it down. There is no short. It didn't like that. There we go. That's why. Okay. And you can see it's idling right at about 800 milliamps. And you can see as it heats up, it trips. And that is normal. That's what this thing is supposed to do. And we're drawing about 1 amp. And I don't see this dropping. It's right at 150 volts. And I am getting some sound. But I'm not hearing any station, so we're going to turn this back off. And let me get the controls set on this on an AM broadcast. Well, our little video here has taken a turn, as always. It's never easy, is it? So, where are we? Where we last left off on the last video, we weren't getting any kind of, it didn't look like we were getting a local oscillator or any kind of signal through the audio. We were getting a little bit of audio if we injected just an audio signal into the audio section, but it was very weak and distorted. But more importantly, we could not trace any signal, and I don't know if I caught this on video or not, but we couldn't trace any signal through the IF or RF section. So it seemed kind of strange. And while I was looking into why it was doing this and trying to kind of get a feel for where we're losing the signal, the electronic circuit breaker tripped. And I thought that was kind of strange. And this is not a perfected circuit by any means. I'm still working with getting it perfected. It does have a few little quirks that will make it false trigger. Never had a problem with it not triggering when it needed to, but sometimes it will false trigger. And there's some reasoning why that is, and I'm working on some different ways to deal with it. But nevertheless, it was not a false trigger this time. When I reset the breaker, everything looked normal. And I thought, well, it was a fluke. Working with it again, and all of a sudden, it trips again. So something's not right. So I reset it again, and I noticed that the current, which was normally staying right under 1 amp, it was staying around 8 to 900 milliamps when it was running. It started creeping up over 1 amp, and it went to about 1.1 amp, and that's kind of where our trip point was set at the time, and it would trip. So I said, okay, something's not right there. So we went to look at it again, and just as the owner described, there was a tiny little puff of smoke, and then the breaker tripped again. So what could it be? This particular tube, which is one of the 6V6 output tubes, didn't look right. You see how dark that is all the way around? And if you start looking very closely at it, I don't know if the camera will pick this up, but you can notice in the dag coating inside there, you can see these little stripes where that coating has been like eaten away. I don't know if we're focusing on that or not, but see it right there? See how the light is passing through that little line right up here? And you could see there's actually a crack in the glass. So this tube has gone to air and has shorted, and that's one of the problems. But beyond that, it still didn't explain why we were not getting local oscillator. You can see the emissions tester. When I first put this on, this tube was only down to about here. And if we look at the other side, it has finally gone good. But this tube is very intermittent. It'll jump around, and it's not the tube socket. And it's very weak. If we take this one out and we put a known good one in that's in really good condition, there's no delay. As soon as it warms up, you can see it just shoots right up there. The other one takes forever. One side is bad. The other side starts out bad and will drift its way up into the good after long enough, but it's a tired tube. It probably will still work somewhat, but I think that's part of the problem. And since this is an emissions tester, since this does not put operating current and voltage on the tube, it doesn't tell you the whole story. So what I found is after the tube warms up, this tube begins to short out as well. And just by having this in there for a very short amount of time, this base is extremely hot. It's much warmer than I would expect it to be just in a normal emissions tester. I'm not really sure what that means, because the good tube doesn't get that hot from sitting in there. So I believe there is the filament is shorting to something in here. It's lighting up, you're getting emissions, but it's shorting. And if you sit there and leave this in the tube tester long enough, the meter will deflect very abruptly like that even on the emissions tester, which really doesn't put a lot of power through the tube at all. So all that being said, we had 2 bad tubes. In addition to that, the detector tube, the 6H6, one side reads extremely weak, the other side reads a little bit weak. It would still probably work, but I'm sure it doesn't help. So we're going to replace the 7F8, and I have a really nice matched pair of Magnavox 6V6s. They're used, but they have really good gain on them and everything, good transconductance and so forth. So we're going to replace those. So the output tubes, the 7F8, and the 6H6 detector tube are all going to get replaced, and then we're going to go back and do our test again. Now, knowing that this tube was so severely damaged, so you could see, and something had to cause this. These don't crack, and they don't get these big arc marks inside of them unless something really bad happens. We want to make sure that there are no shorts. And if we look at the schematic, and I want to talk about schematics later, but we'll get into that a little bit later, because there's a part I probably should have put at the beginning of this video. So, and I might just do that. So anyway, if you look, you have your audio output transformer here. And this transformer should be, it should have some reading of resistance. It should not be a short. It should be at least, they're usually like 100 ohms or something like that. I can actually measure this and kind of show you what a good one looks like. Matter of fact, let's do that. So down here is a known good audio output transformer, and if we measure between the two plate leads, if I don't get my test leads all tangled up, we connect this one here, and we connect this one here. You can see there's like 300 ohms there, and that's normal. They're going to be, depending on the impedance, the plate impedance of the transformer and everything, it's going to read anywhere from 100 ohms up to several hundred ohms to, you know, maybe even up towards 1 kilo ohm, depending on the transformer. But it needs to be something like that. So that's one thing that we're going to want to check here. And let me move this out of the way for a moment. And if we look on the schematics, all of the output tubes, that one of the standard values, you know, is a 6V6, 6K6, 6F6, 6L6, you know, all of those, the, you know, so forth, they all have the plate on pin 3. So we should be able to read between the plate of pin 3 here and the plate of pin 3 here, and we should see something like that. It should be several hundred ohms, I would imagine. So let's look at, here's the key on this pin here, and I'll zoom in a little bit. And so from the key we count pins 1, 2, 3 is going to be this one right here. We'll just get on the wire there, and that's coming from the output transformer. And then we'll go down here, and the key is in the, let's see, is it? Yeah, it's in the same spot here. So we'll count 1, 2, pin 3 here, and we get about 450 ohms. So that looks like our transformer is good. Now, why did I test that? Well, if you look on this particular design, it's kind of a scary thing, but if you notice, there's more than just the plate going to that transformer on both sides. There's 2 wires coming off of them, and they go down here and they go into this rotary selector switch, and this selector switch is used for tone control, so your high, medium, and low audio tone. And what they have in there is they have several different capacitors, and they use them as filters to filter out the high frequencies to make your high, medium, and low tone. And what happens is these capacitors are notorious for developing resistance and eventually shorting out. And what will happen is when they short, they will actually damage that transformer. This still doesn't mean that the transformer is not damaged, but at least we know we don't have a short between those windings there. And if I measure with reference to ground, which this pin is grounded, I'm not seeing anything there either. We're just reading through a capacitor. So that looks good. So we have a good output transformer. You want to check that before you just plug new output tubes, especially when you see a tube that's severely damaged like that. That tube may have been damaged before this thing was recapped by the previous service person, because when that happens, you know, that it could have damaged the transformer, and, well, we don't want to blow a new set of tubes up. That's the bottom line. Okay, let's try this once again and see what happens. Power on. Oh boy. You see it didn't stay on very long and it tripped. I'll go up a wee little bit, but that's all I'm going to do here, because it worked before. You can see it runs a little bit. Boom, goes off. So there is a possibility. There's two possibilities. Possibility one is that with our new 6v6 we have a little bit more current draw. I doubt that it's that much more. Or number two, there is a short in here and it's something related to a vacuum tube or something, that or there's a short that when a tube begins to conduct, the short becomes present, which is more than likely what's happening. First thing we're going to check here is if that short or that high current situation, we won't call it a short because whatever it is, it happens after some time and the current kind of creeps up, and that's what trips this thing. So what we're going to do is, I'm looking at the B plus up here, and it's not the main, it's not the front B plus that goes to the output transformer, but it's the filtered B plus on the other side of the choke coil that goes out to the rest of the radio. I want to monitor that voltage and see if it drops. The other thing I did was, again, removed the output 6v6 tubes that we just put in to make sure that it's not, when those warm up, there's some sort of a short problem or something. And we're going to just narrow down this problem. It's obviously something that happens after the unit is on for a short while. So it's not a dead short that comes on right away, but rather after the vacuum tubes heat up and begin to conduct. So let's start this thing up, and we'll probably have to double clutch this to get through the charging of the capacitors. And that's pretty normal. There we go. And we can see as this comes on, and we have current, and you notice it's not 900 milliamps. I turned the trip point down a little bit also. And boom, do you see that? After it was on for a few seconds, it dropped. So I'm going to turn this up ever so slightly. And you can see our current is up a little bit. This is not a good meter for this thing. I want one that's more... It's not staying on. Okay. I noticed, and I caught it out of the corner of my eye, and I don't know if that was just a reflection on my glasses or what, but right up in here, I could swear I saw a tiny little flash right in here. So let's focus on it. I'm going to take the light away from it. We're going to do this once again. And I don't know if, like I said, I might have been imagining that. It might have been a reflection of the light on my glasses, but here we go again. I didn't see anything. But it seems as soon as that capacitor charges up and you get close to your full B+, this thing trips. And if you, I don't know if I showed it on an earlier video or one of the earlier clips, but I had this clear down by, this dot represents about 1 amp of trip current. So when you're on the red dot, as soon as it hits 1 amp, it'll trip very easily right there. And I'm a little bit above that. It's at about 1.2 amps or something like that. So it's happening so quickly that this meter isn't even registering it. And we can't really see the voltage drop here with the short because, it's happening so fast and this thing's shutting it off. So what I'm going to do, I'm going to increase the trip time to give it a little more time to react. And we'll see what happens. Again, this is still only 16 cycles, and we're looking at 60 cycles per second, so it's still a fraction of a second of overcurrent. And this is not a dead short, so I'm not really concerned about it. So here we go. Yep. Did you see that? Just as soon as that voltage started dropping, this thing tripped. So something, when one of these tubes is heating up, something is shorting out. So because we saw I thought I saw a little flash up there, but I might have imagined it. I'm going to start at the front end. I normally wouldn't. I'd go with the more powerful tubes and work my way back. But I'm going to skip ahead and I'm going to remove the 7F8, which, if you recall, the old one had problems, and I think it had a short in it. It may have damaged something up there. And I'm going to remove the two 6AG5s. So your mixer oscillator and your two RF amplifiers have been removed. We're going to turn this back on now and see if anything changes. Nope, it's dropping down. See it? I don't see the current going up very much yet. I don't see any smoke. I'm looking for smoke. I don't see anything changing now. It's kind of settling down as all the tubes... I think this was dropping a little bit just because all the tubes were warming up and starting to conduct. But it's staying on now. Okay, 6AG5s are back in. Let's start it back up, and I'm going to just drop the sensitivity a little bit, or the trip pulse count. And this is 290. It should go down to 280. And it's dropping big time. Look at it. Boom. Okay. And I see smoke. Just a tiny little wisp right there. I don't know if you can catch it. Right in there. Something in here, which is in line with this tube right here. So let's pull this out. Right there's your smoke. Well, I don't know if you saw that, but see it? That would be our problem. So, yeah, we have a bad tube. Who would have guessed that? I mean, the tube read very strong. I tested it on the Hickok, and it tested good, but I got it narrowed down to where there was just nothing else it could be. So, some interesting things here. So, that capacitor, I don't even know if I can get this camera close enough to show it to you, but it's right down there, right here. See it? I removed it, just this leg, and I measured it, and it's still good, believe it or not. It probably should be replaced, but it's very difficult to get to. As you can see, everything's just buried in there. Everything's all built around it. But it's working. So that led me to look at some other things. And maybe this is where we should talk a little bit about schematics. There are no less than probably 3 or 4 different versions, if not more, of these schematics. So anytime you look at these schematics, there's a number down here. So this one is 89D210-D. There are a whole bunch of different rev levels where they made little minor changes to this thing throughout its life. And some of the changes are very significant. If you have the wrong schematic, you can easily lead you down a rabbit hole and you can get the wrong idea of what's going on. So this is the closest representation that I have, and it's very close to what we have here. And it's not easy to identify either, because you can't just go by the serial number. I have not been able to find a chart that converts the serial number of the unit over to which schematic. So it's really a kind of a research project every time you work on one of these. Anyway, one of the changes I've found is when you look up here, they're showing this capacitor. That's the one we just checked. It goes through a resistor and a inductor that are in parallel. But on the first RF, it just goes directly to ground. In our version, they skipped all this. Basically, this one and this one are wired the same. So this capacitor goes directly to ground. So disregard that. Since there was nothing wrong there, I kind of traced back, and there's really nowhere around here that would cause heavy current to draw, except this line here. So I traced this down, and I went all the way down here and kind of looked at where it connected, and I noticed it connects on this sensitivity control. And I noticed also that there are two capacitors. One of them is 0.25 microfarads. The other one here is a 100. Now, what is that 100? Is it 100 microfarads or picofarads? Because, once again, they don't put the positive and negative marks. So if you look at this over here, this says 30. And notice no plus and minus. This is actually a 30 microfarad electrolytic. They show 20 here. This is a 20 microfarad electrolytic. They're not showing positive and negative. And no, this is not non-polarized electrolytics. That's how they do it on this. They assume that you already know. So I thought, well, this thing had been recapped, but maybe this little 100 picofarad, because that's what this is. I looked it up, and it is C127. You can see right there, C127. And if we go over here, C127, capacitor, 110 picofarads, 5% ceramic. So I went down to our sensitivity control, which is over here. And we can see that gigantic 0.25 microfarad. That thing's huge. That must be a 1600 volt or something. I don't know. It's big. But in addition, going to this tab here is ground. Look at what we have. It's a 100 microfarad. That's not right. Now, I don't know if that's causing the problem, but that's definitely not the capacitor that belongs in there. That's 100 microfarad, and it should be 100 picofarad. So I did not replace it with a ceramic. I replaced it with a silver mica because I had them in stock, and they don't drift with temperature or anything like that. Although I don't know how much that matters in this application, but just in case, we're going to do that. It's next to this hot resistor that gets very hot. So I guess it's left to try and see what happens once again. So let's turn it back on, and like I said, we're probably going to have to double clutch this because all the caps are discharged. There we go. And let's see what happens. I have the tube back in, by the way. I have that 6AG8. And it's dropping down, and boom. Oh, I did see a flash that time. I don't know if we caught it in the camera because it was down so low, but there was a flash. I distinctly saw it, and it's up in here. So that capacitor did not fix it, and there is definitely something in here that is not happy. So I did some tracing, and a couple things came up. You can see this piece of insulating tubing I just stuck on the one end. This is soldered to the chassis for ground, and I just lifted it and put an insulator on it. And that white flash that I was seeing, I was able to reproduce the problem the flash is inside this capacitor. This cap has silver mica disease. And yes, standalone mica capacitors can get the same kind of silver mica problem that those IF transformers get. So that's the problem here. And this is a common issue with these SX42s. These kinds of capacitors are all over the inside of this thing, and they do fail like that. It wouldn't surprise me if some of the ones in the IF transformers are also bad. And we may end up having to get in there, but we're not sure yet. We will have to get to that point. We have to get the oscillator working and the front end working before we can go any further. So the big trick now is, how are we going to get that? Well, I forgot to show you taking this plate off here, but it's still loose. I just have the first screw started. I'm actually putting it back together now. And you can see I have this off. I had to grind that little rivet off down here, and this is up here. So I don't have these soldered in yet, and you can see I replaced both that wax capacitor right here, and I replaced that. This is not a mica, by the way. This is a mica mold, meaning it's actually a foil, paper and foil capacitor. It is not, this one is not mica. It's these things that are called mica mold, they're actually not mica. So I replaced it with a film capacitor, and you can see that in there. And I did not have a 5.6 nanofarad, but I did have a 4.7 and a 1 nanofarad, so I put them in parallel, and that gives us 5.7 nanofarad, which is very close. I also replaced the mica mold, this great big domino one that was over here on this side, and I replaced it with this little tiny one in here, you can see. And that gives you a lot more room up here, and who knows, it's probably leaky as well. So we want to get all that stuff out of there. All right, so all I need to do is put these screws back in, and we'll be back in business. Well, the last capacitor is the most difficult one. If you look down inside there, I actually had to move this trimmer cap. It's actually held in by this little screw here, and it's supported on all sides by wires. And you have to be very, very, very careful, but there is enough flex in them just to move it out of the way a little bit that we can get down in there, and we were able to remove the old one. Now I'm going to put a new one in here, and for this position I'm going to use one of these little radial leaded ones. And yes, I marked the outside foil on this one because it's just in there so tight. I think it would be a good idea to mark this one. So okay, the deed is done, and you can just barely see the little capacitor down in there. And thankfully we didn't damage anything, and nothing's touching or shorting. So the operation was a success. Okay, here's the offending capacitor, and it's a mica mold, meaning it's not a mica capacitor. Even though they're called mica mold, they're not mica. They're actually paper and foil capacitors. So let's test and see how one of these capacitor checkers will test it out. So if you look right there, it reads, this is it's a 5600 picofarad, or a 5.6 nanofarad capacitor. So if we look here, it's reading low, and you can see it's only reading about 50 picofarads. So remember, if this closes and stays closed, that means it's shorting out. And this is down here is the amount of voltage we're applying to test it. So remember, this thing only puts out about 350 volts maximum. So if I rotate this up, right around there would be what voltage was being applied to this thing. And notice it's reading good. And I can go all the way up to 450 volts, and it still reads good. So just testing the capacitor isn't going to tell you how it's going to work in circuit. I guess that's what I'm trying to say. Here's one of those ones that was left in because it was really difficult to get to. And again, we look at the reading here. Right here is 0.05 microfarads, which is what this is. And up here is 0.1. So it's just a little bit. You can see we're getting a little bit of deflection, but it's not really crisp. So it's showing that the capacitor is reading pretty close to its rating, what it's specified as, but it most likely is going to have some leakage. If we go over to the leakage test, we move our voltage up, you can see already we're getting leakage, and it's a 200 volt capacitor, and right at 200 volts you can see it's closing up. So it does have a little bit of leakage, but it's not shorted. And I'm sure if we would have left this in there, it would have worked for a while, but eventually it would, number one, it could degrade the performance of the radio, but number two, eventually it would have failed. So with the patience of Job, I think I've finally gotten somewhere with all of this. The tube was arcing like crazy. I put a known good tube in there. It didn't arc, but it still was having problems, and I still wasn't getting any RF through. So I went through the resistance charts. So I have this resistance chart for the SX42. And anywhere you see pink, there were numbers that were a little bit out of range. Not terribly, but there was one that was particularly bad. And you're allowed plus or minus 15% on these readings, by the way. But this one here, if you look, which is the tube that's giving us all the trouble, you're supposed to have 60K, and at best, I was able to get 5K of resistance, looking at the resistance chart. That's definitely not right, and that's definitely going to cause problems. And that is connected right to the plate of the vacuum tube there. So if we go up here, and we look at pin 5, which is where our problem is. Am I on it? Yeah, see right there. Pin 5, sorry about the bright lights. It goes through this little shielded tubing right here. And it snakes its way all the way around to here. This in turn is just a couple of little turns of Litz wire on this coil right here. So it goes from here, it makes 1 or 2 turns here. It comes out, it goes down into this mess right here, which is another terminal on this wafer switch. Now, after looking at that, came to the conclusion, and yes, I have a resistor removed. I better remember to put that up that goes over here. But anyway, it goes and it goes around and comes out of a little 2.2K resistor, which goes to the back that you can't even see. So it goes way back in there, and then it comes out and it goes through this wire right here, which goes to this top coil, and lo and behold, this top coil was reading shorted to ground. So of course, what's your natural thought? Well, it could be this wire or this capacitor right here, which is shorted, and it's not. These are new capacitors. Or this capacitor is also connected to ground, and it could be shorted, but it's not. So what the heck could it be? So I disconnected each and every individual wire, and this coil was still shorted to ground. Until finally I removed this wire, which goes back up to the wafer switch, and the short went away. And if I measure from this wire to ground, there's my short. Now here's where things get interesting. I don't know how macro I can get with this little thing, but here's your wire, or here's your terminal, and I don't know if it'll stay focused or not, but I'll zoom in until it won't focus anymore. Right there's about the point at which it won't focus. But looking at this little terminal right here, it's a little bit loose, but right now it is not connected. So if I go over here, it is not connected to anything. In other words, the actual terminal, which is inside there, you can just kind of barely see it. It is not touching this. This is not connected to anything right now. So this is hanging, the little clip that pinches the little rotor here is not touching anything. I don't know if you could see that, but it's not touching a thing. Right there. Yet, when I touch right on here, there's the short. Look at that. Unbelievable. Now the only thing I can see down here is, you can't see because it's not focused, you can see that black tarnish in there. Again, these switches are embalmed with this whatever it was, deoxide or something. But this wafer is shorting to ground. And we're going to have to figure out if and how we can fix it. So there's the best I can do, and you can see I put some glue around it. I had to remove that out of there, take this pin off, remove that little clamp, which was really hard to put back on. I ended up soldering it on the other way and then pinching it around this side and then putting some 5-minute epoxy resin on there. And of course, in the process of doing that, the pin fell and I lost it and I couldn't find it. So I had to steal one off of here. You could see where I left the clamp on, and put it onto here because that one was an unused pin. Anyway, everything's connected back up. And if I take the probe here and I go back onto pin 5 like I'm supposed to, now we get our resistance. It's near 100 and some 180K or whatever it was supposed to be. So it's fixed. Now, does that mean it's going to work? Well, I have my doubts, but we're one step closer. All right, for the moment of truth, we now have, I have the 6v6s back in. The whole thing's put together for the most part. Let's see what happens. Alright. If I was going to redo this box, I would change the startup delay for more allowance for caps to charge and so forth. Okay, with our 6v6s, this should stay around 250 volts again. This is staying under 1 amp. There is no smoke. And I still have a little scratchy volume control, which at least tells me that we're getting something. But there is no activity on the antenna or on the RF. Okay, first of all, let's inject just an audio signal into the amplifier and see if we get at least sound. And we're going to inject it right at the volume control, which is going to be right, where are we here? Right here. So you can see here's your phase splitter and so forth, and your push-pull output. And we're going to go right into the input of the pot. And yep, not super high gain, but we do have a nice clean signal. Okay, here's 455 kilohertz, and we're going to put it into the first IF, and nothing, not a thing. So let me poke around and see if we can get IF anywhere here. Well, I'm feeding 455 kilohertz into this, and listen. Can you hear that? Yeah, that sounds like a bad capacitor. and I think we have some bad mica capacitors inside the IF transformers. And that's a known problem with these. I've read in some forums of people having bad shorted capacitors in almost in all of the transformers. So who knows? I do know that I went all the way through this and I cannot get it to pass an IF signal anywhere from up here where it actually comes out of the mixer oscillator all the way through the first and second IF stages, all the way into the detector. I'm not getting anything. But if I feed an audio signal into the input of the audio section, I get nice audio. So we're not getting anything. And even if the oscillator itself was bad, it wouldn't matter. If we feed 455 kilohertz into the IF, you don't really need the mixer oscillator section. All you need is the 455 with the modulation. So it's something down here we're seeing a problem. So this is going to be a really fun you hear it going? That's a bad capacitor. That's a shorted mica capacitor. Absolutely, without a doubt. So let me shut it off.